Hi everyone, we're going to talk about section 4.3, another form of the equation for a linear relation. So we're going to consider the relation y equals 2. Can we make a table of values to represent this line? So here's my table of values below. What this equation is saying is that the y value is always 2, no matter what. So all the way down the y column, I'm going to put the number 2. In the x column, it actually doesn't matter what we put. X can change. So I could put, for example, like a -5, or maybe a -2, or 0, or 1. It really doesn't matter, or 6. So if I wanted to plot these points, x is -5, y is 2. So I'd go negative on the x, which remember that is going left. 1, 2, 3, 4, 5, and then +2 for y. Positive goes up, and I would put my point. Or for example, the second point, -2, 2. So -2 on the x goes left 2, and then up 2. 0, 2, so 0 for x means we don't move left or right, we just stay on the y-axis, and we go up by 2. 1 and 2, and 6 and 2. 1, 2, 3, 4, 5, 6. Now, I could have chosen any other values, but you'll notice a trend. All of these points are following along the same horizontal line. So what we can do is connect these points along that line, making sure we put arrows on the ends, because that line will continue going both directions forever. Okay? So this would be the line for the equation y equals 2. The y value is always 2. It will never change. What do we notice? It creates horizontal, whoops. It creates a horizontal line. Okay, now let's consider the relation x equals 3. Create a table of values and then draw a graph. So now this is saying the x value is always 3, no matter what. So I'm going to fill in all of the x values with 3. The y value is the one that can change now. So I could have anything for y, like -4, or -1, 0. Maybe I have 2 or 5. Okay, so now when I go to plot these lines, we're going to see a different trend. Let's use a different color here. I'm going to plot it on the same graph. So I have 3, -4. X is 3, 1, 2, 3. And y is -4, 1, 2, 3, 4. So there's my first point. My second point that I had there was 3, -1. So again, over 3 for x and down 1 for y. Then 3, 0, and 3, 2. So 3, 0, 1, 2, 3 on the x, 0 on the y, so we don't move up or down. And 3, 2. And my last one I chose was 3, 5. Right there. So now you're going to notice that these points are lining up on a vertical line. What I'm going to do is connect those. Making sure I put arrows on the ends. And we should put a little note for ourselves down here about what we notice. It makes a vertical line. And because we have two lines, I know I did different colors, but we should actually label these. We're going to call this first one line A. So I should label this as A. And the second one, we're going to label it as line B. You could also label it as line 1, line 2. It really doesn't matter, but you should make sure if you have more than one line on your graph that we know which one is which. Okay? Another option would be to use a highlighter. Okay, so in summary, the graph of a relation y equals b, where b is any number, is going to be a horizontal line. So if you have y equals, you get a horizontal line. If you have x equals, and again, this a can be any number, we would get a vertical line. Okay, so x equals is a vertical line, y equals is a horizontal line. We're going to draw these lines. If we notice that you only have one variable, which is in this case x equals 1, x is always 1, x cannot change. So that means I can't move left and right. The only option I have is to go up and down. So this is a vertical line. Oops. And let's draw this on our graph. I'm going to use blue for this one. Okay, and I need to make sure I label it because we're going to draw all of these on the same graph and put arrows on the ends. All right, the next equation I see, when I look at this, I see only a y value. So that tells me I'm going to have a horizontal line. In order to know where this line goes, I need to actually isolate y. So that means I need to bring this 4 over to the other side. So I need to subtract 4. And I end up with y equals 2 take away 4 is a negative 2. This is where my horizontal line needs to go. Okay, so at a y value of 2, up here, I'm going to draw my horizontal line. I'm going to put arrows on the ends. And we are going to label it as graph B. So I'm just using whatever letter I see on the side. Okay, my next one. When I look at this equation, I see only an x. So that means I have a vertical line. In order to know where to draw this, I need to isolate x or get x alone. So that means I need to divide both sides by 2 because I have to multiply by x. And opposite of multiply is divide. And that will give me x equals negative 7 over 2. That would be the same thing as having negative 3/2. Sorry, negative 3.5, not 3/2. Okay, so I'm going to draw a vertical line at negative 3.5. 1, 2, 3.5, somewhere here. Whoops. Right there. And we're going to label this as graph C. Okay, and the last equation, I see I have only a y. That means we have a horizontal line. And we need to isolate the y value. So that means we need to subtract 4 from both sides to get the term with y alone. This leaves me with 3y equals negative 9. And then Opposite of 3 multiplied by y is going to be divided by 3, which gives me a -3. So my horizontal line needs to be up here at a -3 for y. 1, 2, 3. And again, we're going to put arrows on the ends and label it graph D. Okay, now let's take a look at an example that when I look at the question, this looks different than the lines we were just dealing with. And I notice I have both an X and a Y. We call these oblique or slanted lines. Because it has both X and Y. Okay, so anytime you look at an equation and you see both X and Y, you know you'll have a slanted or oblique line. If you have just Y, you will have a horizontal line. If you have just X, you'll have a vertical line. Okay, so this question is asking us to make a table of values for -3, 0, and 3, and then to graph the equation. I'm going to start with just making my table of values over here on the side, and then I'm going to show my work beside it. So the X values they want us to use are -3, 0, and 3. The first one is going to be X is -3. Remember, wherever you have an X in the equation, so I'm just going to write the equation down first. You're going to replace this X with -3. Ooh. Once you do that, you need to isolate y. So I'm actually going to do some multiplying here first before I isolate. I have 2 times -3, which is -6. Subtract 3y equals 6. We want to get this term with y alone. So that means I need to move this -6 by adding 6 to both sides, which leaves us with -3y equals 12. And then divide by -3. And I get y equals -4. Put that into your table of values, and that gives you a point on your graph. If you want to draw the point right away, you could. -3 and -4 down here. And then go and find your other point. So now I need to find when x is 0. Show us that you substitute 0 in for x. Do your multiplying. 2 times 0 is 0. So I actually don't need to write it if the answer is 0. And that means I have -3y equals 6. We need to divide that -3 out. And that leaves us with y equals -2. And I can put that into my table of values. When x is 0, y is -2, and plot the point. Okay. Okay, one more point to find. When x is 3, replace that x value with 3 now. Do your multiplying. We need to take that 6 over to the other side. It's a positive 6, so that means I need to subtract 6. And then divide by -3. 0 divided by anything is 0. So that means I have another point at 3, 0. 1, 2, 3 on the x, 0 on the y. These 3 points should be lining up to make a straight line. If they don't, you know you made a mistake with 1 point. So you need to take a look at your work and figure out where that mistake happened. And then, because this is not a word problem, and we can have half values, we need to connect these with a line. And we want to draw it all the way straight through. And remember your arrows on the ends. Okay, so that is how you graph horizontal, vertical, and oblique lines. Bye for now.